So I'm going to assign the first center at some point x, and this assignment can be arbitrary. I pick some point as the first center. It doesn't matter what I pick. Okay? This is for our set. And now I'm going to define a set capital CI, which is going to be C1, C2, all of these centers up to CI. So I'm going to have a partial set of my centers. So after I've set this one point, I have a set uppercase CI, C1. Right? So now I'm going to have one for loop for I equals 2 to k. What I'm going to do, I'm going to find x in x. I'm going to find r max x in x of x minus p ci. Right? So I'm going to find the point which has the largest phi value with the centers I have. This is minus 1. So I have a set of I minus 1 centers, and of those centers I'm going to find the furthest away point. I'm going to set Ci equals to, let's call this x star. I'm going to set it to x star. That's it. All right, so I just find the point that's furthest away from all the other points. From all the points I already have as centers. Not from all the points, but just from the centers I have so far. And I put that in my set of centers. Okay, so let's go through and simulate an example of this algorithm quickly. And just to show you how well this typically works. And we'll go back and review this and talk about some other versions of this on Wednesday. I'm going to pick some point here arbitrarily. This is going to be C1. Now I'm going to find the furthest away point here. The furthest away point is probably down here. So I set this to be C2. And let's say I want three clusters, so K is 3. So I pick the point that's furthest away from either of these points. Furthest away from the closest of them. And let's say that's this point. That's C3. Okay? So now if I look at my assignment, it looks pretty good. It's pretty simple. So it has a weird bias where it picks points on the outside from the points further away from other points, kind of on the boundary. But if your points are pretty clusterable, they divide pretty well, you're still going to probably find the right clusters. We'll talk about some bad cases for this and some kind of a fairly recent algorithm in the last 5 years that kind of has some needs improvement on top of this. But this is already a 2 approximation to this, and that's as good as you can do for K-sum. And it's very fast. It takes K squared times n time.